Okay, now we're going to work on composing functions, inverse functions, general sketching of graphs of functions, and then 3 polynomial theorems to make it easier to graph functions. All right, we're going to start off with composing functions. So composition of functions. So that's when you might take, say, 3x squared plus 2x. Well, this by itself is a function. This by itself is a function. When you add them together, you create the sum of two functions creates a completely new function. So if this is f and this is g individually, when you add them together, they might equal h, just like this right here. Okay? So there's adding functions, subtracting functions, multiplying function. You guys do that with binomials. We've done that a lot. Then there's dividing functions. We did that with long division and synthetic division. And then finally, there's what's composing a function inside another function. So we're going to practice each of those. So here we have, we're going to add g of x to h of x. So you're going to take this function right here and you're going to add it to this function. So just like this. So here's the h and we are adding the g function. Another way to write h plus g, we could call that a completely different function. We could say this new function, h plus g, is called f of x. All right, so then you're just going to add things together. 4x and 2x will add together. 2 and negative 1 will add together. And that is our new function. So if at the beginning you said, I'm going to let h plus g of x equal f of x, then instead of writing this each time, you could just write f of x is equal to 6x plus 1. All right, now I'm going to cover all this stuff up. We're going to do a subtract problem. All right, so we're going to subtract the f from the g right there. So if I say let f subtract g of x equal h of x, I can now just say h of x is equal to the f function subtract the g function. So h of x equals, so let's see, well, there are no other x squared, so this just says subtract x squared, so negative x squared, so I took care of that. And this says subtract negative, so that means that's a positive x. Now look at what we have, 2x plus x, which is 3x. And then we have a 2 and there are no other numbers, so we're just going to say add 2. All right, we're going to go on to the next. Now we have multiply. Well, you've been multiplying for a long time. So again, if I say I'm going to let f times g of x equal to h of x, instead of rewriting that stuff, I can just say, okay, I'm going to call this h of x now. So look at what we have. We have 3x times that whole function, and then we're going to do the distributive. And you called it h of x. So 3x times x cubed is 3x to the fourth. Subtract sign, 3x times 2x squared is 6x cubed, just like that. All right, I'm going to cover this up. Now we're going to do a divide. The cool thing about most of these, and I'm going to let that equal f of x, so I don't have to rewrite this each time. Oh, It would be f of n. So f of n, sorry about that. It says you're going to take this h function and you're going to divide the g function. So negative n plus 5 divide n squared subtract 5n. If all four terms had an n attached to it, you could cancel an n. If all four terms had a 5 in common, you could cancel a 5. But because they don't, this is actually as simplified as you can get that. All right, I'm going to move on. Now we have a function inside a function. This notation right here, h, that reads h of g of x right there. That little hollow dot is the word of. So h of g of x. Normally between two things it means multiply, but this notation right here means you're going to take the g function and plug it into the f. So what I mean by that is this g function replaces that x. So this is what it would look like. Notice in the blue, let me get the blue. See this 3x subtract 3? 3 instead of x, I put parentheses, 3x subtract 3. And where that parentheses is, I took this entire function and put it into the parentheses. Now I could still say right here, if I said h of g of x, I'm going to call that f of x. Instead of all this stuff right here, I could just say, now look at what I did here. I did 3 times x, which is 3x, 3 times 3, which is 3, and then I brought down that subtract 3. Well, 3 subtract 3 cancels. So now the new f of x is just equal to 3x. All right, now you're going to evaluate a function. Evaluate simply means do the math using the numbers. Well, we're going to take this -1, and everywhere there's a t, we're going to plug in -1. Notice what I write. I write f of -1, because instead of t, we have -1, is equal, look at that t, instead of t, I'm going to put a parentheses. So -3t squared subtract t. So where there are variables, the variable t, I put parentheses, and now inside the parentheses, -1 squared cancels to 1, and now -3, well, here, I think I simplified that further. I plugged in that -1, and now -1 squared is +1. -3 times +1 is -3, and subtract a negative becomes adding a +1. So f of -1 is equal to -2. That would be your final answer. Now, instead of a value, that actually tells us we have this expression. So everywhere there's an x, we're going to plug in that expression. So at the beginning, instead of putting p of x, I write p of -2x, because instead of x, I'm going to write that. And then what I did is I took everywhere there's a variable, I put parentheses. So this says x squared, so parentheses squared plus 1, subtract 2x, so subtract 2, parentheses. And now inside the parentheses, I go ahead and write negative 2x. Well, negative 2 squared is positive 4, and x squared is x squared. So all of this simplifies to 4x squared. And then there's still our plus 1. And then 2 times negative 2x. Sorry, I just had a sneeze. I should point out negative 2 times negative 2x becomes positive 4x. But then you have to put everything back in order. So the 4x squared goes here. This positive 4x is going to be put next to the x squared because we want it in order of powers. X squared, x to the first, x to the 0, so we don't have to write it. So this right here is the final simplification.